All right, check this out, y'all. Now we're going to be solving rational inequalities. Now it gets a little bit tricky here, but nothing too hard that we can't handle. So we're going to solve each inequality, and then we're going to graph the solution set. All right, so the way that we handle rational, and again, the reason why that's called a rational inequality is because the fancy word for rational is a fraction. So we have fractions now. And the way that we do that is we want to make this number 0. So what we do is that we actually move this constant number over here to the left here. So I'm going to go ahead and subtract 2 from both sides. So that means now I have 8 over x minus 2 minus 2 is greater than or equal to 0. So all I do is I just move this 2 from the right side to the left side by subtracting by 2. All right. So now what I'm going to do is that we actually want to combine these two by getting a common denominator. Okay, and so what I want to do is I want to multiply this top and bottom by x minus 2. So I'm going to multiply the bottom by x minus 2. And I'm going to multiply the top by x minus 2. Okay, because x minus 2 over x minus 2 is really just 1. So we're not changing the problem, just the way that it looks there. So over here now that I have a common denominator, I'm just going to write x minus 2. But on top I have 8. Right, I have 8. And then this is a negative 2 right here. So I have negative 2, but then I still have to multiply by x minus 2. Okay, so just take a look at what I just did there. I combined my two rational numbers into one rational expression now. Okay, and I make one denominator because they have a common denominator of x minus 2. And I did 8 minus 2 times x minus 2, and I put them all together right there. So now let's simplify this some more. So I still have my denominator of x minus 2. And now I'm going to go ahead and do the distributive property and get 8 minus 2x plus 4. Because I bring down the 8, and I do negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. All right. And I can combine the 8 and the 4. And so I'll just get 12 there. So 12 minus 2x all over x minus 2 is greater than or equal to 0. Okay, so that was the first step. Okay, the first step to solving rational inequalities is first move the constant number that's to the right of the inequality over, and then you need to add or subtract whatever the sign is right here. Add or subtract those two rational numbers. And that's where we're at right now. We have 12 minus 2x over x minus 2. The next thing what you need to do is you need to find the zeros of the numerator and the denominator. So set the numerator equal to 0. So 12 minus 2x equals 0. And set the denominator equal to 0. X minus 2 equals 0. So if I do that here, I'm going to subtract 12. And then I get negative 2x equals negative 12. And I'm just going to move this guy down. And then I'm going to divide by negative 2. So x equals 6. Okay, so just keep that there. We need that. And then we're going to add 2 here. So x equals 2. Okay, so but what's really important to note was that this answer came from the denominator. And this answer right here came from the numerator. Now you say, well, what's the point here? This is important because we know that in any fraction, we cannot divide by 0. So when I say, oh, x equals 2, if I were to really plug in a 2 right here, 2 minus 2 is 0, right? I need to know that this 2 came from the denominator because when we refer to the 2, we're going to use a parenthesis. Because the 2 cannot be included. You can't include 2, because if you include 2, then you're going to put a 0 in the denominator. But here, you can plug in 6. 6 came from the numerator. I mean, you can plug in 12 minus 2 times 6 is 0, right? Like on top. But you can divide 6 divided by 4, because 6 minus 2 is 4. You can do 0 divided by 4. That's fine. You just can't have 0 in the denominator. So here, we're going to use a bracket when we refer to the 6. So maybe this will make more sense when we draw out the number line. but it's real important that you just notice that these two answers, which one's going to have the parenthesis and which one's going to have the bracket. Whatever number you get in the denominator, you will always use a parenthesis. Whatever number that you get in the numerator, you will always use a bracket. Okay? So now that we have our two values, we're just going to use the same process that we've learned from the quadratics or the polynomials. We're going to make a number line. We're going to plot those two values, and then we're just going to test the values. All right? So we have the value of 2, and we have the value of 6, and we have A, B, and C. Right? So now we just got to plug values into here and see when it's going to give us true or false. So let's plug in a number that's to the left of 2. So maybe if we try x equals 0, let's just remember what is the original problem here. So you could either use this problem right here. Okay, so you can use this one, or if you want it where it's bigger than 0, you can use this guy. So, because they're all equivalent, it doesn't matter. So if you want to use this guy or if you want to use this, basically we're just looking for a true answer, right? We want to know when is it true and when is it false. So I'm going to use this guy right here. And so I'll just copy this guy right here. Oops. So really, I just want this guy. All right. So let's go ahead and plug it in and see what we get here. And I'll bring this guy probably down over here. All right, so I'm going to plug in 0 right here. So 8 over 0 minus 2, is that bigger than or equal to 2? Well, 8 divided by negative 2 is negative 4. Is negative 4 greater than or equal to 2? Well, no, that's false, right? So this side over here is going to be false. Okay. Now let's plug in a number between 2 and 6. And maybe we'll just do 3. So 8 over 3 minus 2, is that bigger than or equal to 2? So is 8 divided by 1, is that bigger than or equal to 2? Well, yes, right? 8 is bigger than 2, so this is going to be true. And a number bigger than 6, 7, we'll just use 10. 8 over 10 minus 2. And then we have 8 over 8, is that bigger than or equal to 2? So you have 1 is bigger than or equal to 2. Is this true or false? Well, that's going to be false right there, right? So this is false. So check it out. The only time that this was true was between 2 and 6, right? Now, which one has a bracket and which one has the parenthesis? And that's where this comes into play now, this whole tad bit. The 6 had the bracket, and the 2 had the parenthesis. So this would be the answer right here. This is when it's going to be bigger than or equal to 2, but it's not including 2, meaning you can't plug in 2. Because if you plug in 2, just like right here, then you're going to get the answer is impossible. If you can't divide by 2, you get like an error. It's not real. You don't get any kind of answer, really. It's not possible. But you can plug in 6, right? 12 minus 2 times 6 is 0 on top, but you can plug in 6 on the bottom, and you have 0 divided by 4, which is fine.